Yeah, welcome guys. Welcome for day 10. So sorry for delay. So I have some technical issues, so I joined late. So thank you for joining. So is my voice is clear? I'm audible to you. Can anyone respond in chat box? So I have some delay issue here. Can anyone respond in chat box? Is my voice is clear? Are you able to? Is my voice is clear? I'm audible to you. Can anyone respond? Yeah, okay. Yeah, sorry for delay. So today we are gonna see FSM, more emission, how to write the Verilog code FSM in today we are gonna see, and also we will see the difference between overlapping and non-overlapping. So it's an we have two FSM like Mealy and More. So Mealy having non-overlapping and non-overlapping method, like a kind of machine, state machine, and also More also having the overlapping and non-overlapping. So today we will see both of them. So sorry, today we are gonna see only More machine. So More machine overlapping and non-overlapping. Tomorrow we will see the Mealy machine. So this is for today. So we'll try to write code for the FSM More machine with overlapping and non-overlapping with single code. So we'll see in this session. So thank you for joining. So thank you for all your presence in this master class. So let's get into session. So very good evening to all. Welcome to you all. So let's start the session. So we know that state machine is yesterday also we seen what is state machines. So same like that. So FSM is an abstract mathematical model of a sequential logic. It has finite input, finite output, and then finite number of states. So these all things like input, output, states, it is all things based on our inputs only. So it is also these all things based on our requirements, our conditions. So if you want to decide, if you want to build one circuit or a complex circuit, it is depends on you only. So what you think, so what your logic. So you can use a number of state, like you can use less state, you can use more state. So it's based on our your knowledge and your skill, and how to say your logic only. So but it must contain finite states. So we know that how many state it have to do. So it must be have. So this is based on our condition. So we know the states, we know the inputs, so we know the outputs to get the output. So we can say that it is a finite state machine. So let's see we know that it's have two types, Mealy and More. So and then so this is a circuit diagram for our working of More machine. So we know that More machine is works based on current state input only, not a previous state output. Mealy machine works like a current state input and also previous state output. Yeah, you can see here. So this is the working of More machine. Next state output. So this is one deep flip-flop here to store the values, to store the data. So you can see after the next state. So this is my current state. So after the storing the some particular value, this is my current state. So my next state logic depends only the current state only. You can see this is the logic for next state. So in this block only we are writing the logic for to move the next state, but this next state logic is depends only the current state input. So current state and inputs. So we can so we can say this is a more logic, and then we'll move to the Mealy. So if you take in Mealy means, you can see here it is based on our current state. So this is the current state So you can see the after the memory elements, we have the current state output, so current state value. So the next state logic is depends on current state and also previous output. So this is my previous output. So you can see here the arrow mark here from this output logic to next state logic. So it is depends on both current state input and then previous output. So this is a Mealy logic. So this is the Mealy working. So it is based on current state and input, and then current state input and also previous state output. So this is a difference between both of them, Mealy and Mealy and Moore. So this is the difference. So today we are going to see only Moore logic. So we'll try to write for FSM Moore logic, so like a sequence detection. So we know that each and every types like a Mealy and Moore, it having two methods like a overlapping and then non-overlapping. So overlapping is nothing but, so the FSM can reuse the part of the detected sequence for the next detection. So you can see here the FSM can reuse the part of the detected. So already we have one detected sequence. So if I use the part of the value for the upcoming detection, so you can say that is a overlapping. For example, if I'm gonna to detect the sequence like a 1 0 1 1 1 0 1 0 1 1. So this is my first detection, 1 0 1 1. This is my first detection, but after consecutive term like a consecutive bit like a 1 0 1 1 it have. So in this first detection, so 1 0 1 1 is my first detection. So in the last bit of my first detection, it gonna be first bit of my second detection. So it's like a overlapping. So you can see here it will if you detect this sequence means you will get two detects. So it detects the 1 0 1 1 twice. So we can say this is overlapping. So non-overlapping means it won't detect the two sequence same input. So you can see here 0 1 1 0 1 same input sequence, but it will detect only once. So it will detect only one sequence only, not yet two sequence. So after that one sequence, it will move to the reset condition. So it will move to the initial state of the sequence. So it won't detect the second sequence from the previous previous detected output. So this is a difference between overlapping and non-overlapping. So we'll try to write the code for overlapping and non-overlapping in the FSM machine. So this is the thing. So this is the working of the Mealy, this is the working of the Moore. So I just want to show one thing, what is Mealy and Moore, what is overlapping and non-overlapping. So you can see here, I will write here. So firstly, I'm gonna tell you what is overlapping. Overlapping. So overlapping of Moore machine. So I have to detect the sequence of 1 0 1 1. So this is my sequence I have to detect from the input sequence. My input sequence is, so my input sequence is like a kind of 1 0 1 1 1 0 0 0 1 0 1 1 and then 0 1 1 and then 1 0 1 1 1 0 1 1 1 0 1 1 1 0 1 1. So it consists of n number of inputs. So like it is a continuous input signal. So inputs binary bits. So we have to detect this particular 4-bit from this sequence. So this is the sequence detection. So operation of the working of the sequence detection is nothing but from the input sequence it have a lot of binaries. So it have a lot of sequence like a continuous sequence. we have to detect this particular sequence from this sequence. We have to ensure that this particular sequence exist in this sequence. So my output will come like this is for output. So firstly it will check this. So we have 0, so sorry, we have 1 and then 0 and then 1. So after that, here in the last bit of sequence, output will be 1. So it means this one is this one is for referring the I got one sequence from the input. So it means it is successfully find the first sequence like a 1011. This is my first sequence. So for knowing purpose, for understanding purpose, I just give like 1 here. This means if it is 1 means I am successfully detected my first sequence. So and then it will move to check remaining binary inputs like a 0 0. Here I don't have any sequence. So you can see here is my one. This one is my first bit of my sequence 1 0 1 1. This is my first sequence. Here it 1 and the same thing. So if it is overlapping means it will check the current bit also. It will check the current bit. So 1 0 1 1. So here I will write 1 here. Why? Because of so this is this one. So this is first sequence. So this is the second sequence I detected, and then the third sequence it take a part of input from previous output like this is a previous output. So I'm taking the last bit of the previous output to for my first bit of my next output. So it means it is overlapping. So it use the previous output to detect the next output. So basically it use the previous output part from sequence for detecting the next output. So this is means overlapping. So if it is not overlapping means here I didn't get any output. So it won't take previous sequence data. It will start from newly. It will go to reset condition. It will start from newly. It will continue searching the sequence from these inputs repeats. So after that it will come here. So here it also 0 1 1. It is not my sequence. So it will come here. You can see 1 0 1 1. So this is my sequence. Here I am getting. So here I am get 1. So this is means non-overlapping. So overlapping means it will use the previous output. It will use the previous output to detect the current to find the next input. So to find the next output. So basically it will use the previous output to find the next output. So this is working of the overlapping and non-overlapping sequence detection. So we'll try to write the code for this. So our output will be, so our input of FSM will be like this, continuous binary inputs. So our output like this only 1. So 1 means it refers to I got output. So this is the things. So and then so this is a sequence state diagram of sequence data of 1011. So now let's see how it is works. So if you write the FSM for Moray, you have the additional one state. So if you want to detect the 4-bit of sequence, we just want to add additional state 1 bit. So it's like a n plus 1. So n means number of bit, so 4, and then plus 1 means 5. So you have to use for 5 state for the writing the more machine. So I'm going to use 5 state. So if you are using the Mealy, you just need a number of, if you have 4 bit, you just need to write FSM for only 4 bit. If you are using Moore, if your input sequence, if your sequence is 4 bit, means you have to use for 5 bits, so 5 states. So firstly I'm just written my state like a S0, S1, S2, S3, S4. These are my states, totally 5 states. So S0 is, it refers to initial state. So S1 it will store the first detected output, S2 it will store the second detected output, S3 store the third detected output, S4 will store the fourth detected output. So this is my initial state. It will store the S0 state only will instate the sequence detection. So in the S1 state it will store the 1, in the S2 state it will store the 0, in the S3 state it will store the 1, in the S4 state it will store the 1. So 1 0 1 1. So this is the FSM. And then let's see, you can see here S0 by 0, it means this 0 is refers to output. If my successfully detected my output like a 1 0 1 1, here it will check state by state. So if I got my output like a 1 0 1 1 sequence, if you get output, means you will get out, you have to give like assign like a output equal to 1, otherwise you have to give 0 only if you got output, means you have to give 1 here. And then if you didn't get an output, means you have to give 0 for each and every state. So in this state I don't get any output, so 0. In this state in this state also I didn't get output, so I just put 0. So in this same like in this state, same in this state. But in the fourth state, so in the fourth state I will get my outputs, I just give 1. This one is refers to output. If it is 1, means I got output here. So this is the functionalities. So let's check for state transition. So state transition is based on the input. If input is 0, means, so we can see, so based on our input it will move to next state. So if my input is 0, means for S0 state it will stay in the same state. Why? Because of I need 1 to move for the first state. So if the S0 state input is 1, means it will store in the same state. If it is 1, means it will move to the next state. So my next state is S1, so it will come here. So it having the 1 value, so our sequence output 1 value. S1 state it store the 1 value, and then it will check. So each and every state having inputs like a 0 and 1, so binaries. So if it is 0, means, so our next bit is 0. If it is input, if S1 input is 0, means it will move to next state. If it is 1, means it will stay in the same state, S1 state. Why? Because of there is another chance. So our sequence bit is start from 1 only, 1 0 1 1. So it start from 1 only. There is another chance to get 0 in the S2 state. So it will stay in the same state S1, and then it will move to, if it is 0, means it will move to the next state. So in the second state, S2 state, it will check for inputs. Like if it is 1, means, so my next input is my next bit is 1. So if it is S2 state input is 1, means it will move to the third state. If it is 0, means it will move to the S0 state. Why? Because of, so you can see here if I 1, means it will move here. If you take this S1 state, if it like F1 state, it will move to the next state. If it is 0, means, if it is 1, means it will stay in this state. So you can see here 0 means it will move in the for we take this example. So S2, so S2 means it S2 storing 1. If it is 1, means it will move here. It will if it is 0, means it will it will move to the S0 state. Why? Because of there is no chance to resume our detection. So if you take this example, here 1 means it will stay in the same state. Why? Because of there is another chance in the S2 state will get the 0. So our detection is 1 0 1 1. So here it having 1, already it having 1. So in the second state, if it is having 0 means it can go to 0. But if you can see here S1 state having, S2 state having 0, so 0, and then if you say S2 state is 1 means it will move to next state, or 0 means it will go to S2 state. Why? Because of if it is having the 0 means there is a sequence like a 1 0 0. So this is not our sequence detection. We need only 1 0 1 1. If that is the reason only. So that is the reason it will go to initial state to start from initially to start from beginning. So this is the reason. So if I give for the same state like S2 state, it will kill my sequence. So if I give for this, if in this state input equal to 1 means, if input is 1 means it will move to this state. If it is 0 means I will give like a same, it will stay in the S2 state means it will my sequence like a 1 0 0. So this is not my sequence. So it will kill my sequence. So that I am just assigning. So I'm just saying like you have to start from beginning. So that I am assigning. I am going, if you in the S2 state, if it is 0 means it will move to the S0 state. So this is a logic. So in the S3 state, so you can see in S1 state having 1, S2 state having 0, S3 state having 1. So if in the S3 state, if it is 1 means input is 1 means it will move to this state like S4 state. If it is 0 means it will move to the S2 state. How means? So why it will move to S2 state means, so S2 state having the 1. So in the next state it can be like a 1 0 1 0 1. So if it is 0 means it will move to the S2 state. Why? Because of S2 state having the 0. So there is another chance. So 1 0 1. So there is a chance to getting the sequence again. If there is no chance to get the sequence again means you have to start from beginning only. If there is chance means you can go for that particular state like this, like this state will go to second state if input is 0. So this is the way, this is a logic. If there is a chance means you can go for the previous state. If there is no chance means, there is no chance for getting the sequence means you have to go for the initial state. You have to start from beginning. And then in the fourth state, if the input is 1 means, so I will get my sequence. So 1 0 1 1. If my input is 1 means I will get my sequence. So it means I got output. So you can see here 1 is declared. So S4 state 1 means I got output from fourth state, S4 state. So if it is 1 means it will go here to start the sequence from 1 0 1 1. From here S1 state having 1, so that it will go to here. And then if it is 0, it will go to initial state. So this is a non-overlapping, so it won't overlap. So it won't use the previous state output of the next for finding the next sequence. So it will go to the initial state like a S0 state. Same thing, if it is go to the next state means it's overlapping. You can see here already S1 state having 1, so it will go to S2 state. If the S4 state having the input of 0 means it will go to the S2 state. It means overlapping. Why means there is a chance like here it is having 1, so my input is also for S4 state is 0. So 0, it will move to here. So it can make the other sequence. So it will, by using follow this overlapping, we can find the another sequence by using the previous sequence outputs. So this is overlapping and non-overlapping. So if it is in the last state, S4 state, it will goes to initial state, means it is a non-overlapping. Or else if it is last state input either 0 or 1, if it is goes to some part of the our previous sequence, means we can say this is a overlapping. So this is a difference between overlapping and non-overlapping. Remaining thing also same only. This state transition, and then these are the same only. If in the final state only, S4 state only, we have to check if it is go for initial state or if it is go for that some part of the state in my sequence, means if it is go for some part of my sequence, means we can say this is overlapping. If it is goes to the initial state of my sequence, means we can say this is non-overlapping. So basically S0 is like a reset or restart state. So this is some query have like a total bits are 4 but states are 5. So this is a more if you want to write a more logic, you have to follow this only. So why? Because of each and we got the output from the last state. If you are writing the Mealy machine, you got output from the transition of the state. But if you are writing the more machine, you will get the output at the state current state only. So you will get the output based on the current state only. For that reason, we are using the additional one state for more machine. So my sequence selection is 4-bit only, but I am using the 5 states. Why? Because of my in the Moore logic, output will be output in the will get in the state output only. So each and every state only I will get my output. But in the Mealy logic, output will be get by transition of the states. So tomorrow we'll see the Mealy machine, then only you can easily understand why Moore machine will use the additional one state. So Mealy machine give output from the transition from the transition of one state to another state, but Moore machine give the output based on the current state inputs and outputs. So there is a difference between the overlapping and non-overlapping. If it is going, if the last state, if it is go for initial state, means we can say it is non-overlapping. Or else if it is go for some part of the sequence, means we can say this is overlapping. Yeah, n plus 1 state. So and then so this is the difference between them. So we'll move to the. So yeah, if you guys are really interested, you want to make a 1-month internship from this masterclass, you can use so internship on FPGA. So these are the benefits. You will get the benefits from the 1-month internship, like all 30 days recording session, all 30 days presentation, exclusive project codes, VIP community group for your doubt clearing, and then you will get the internship confirmation letter from IET, and then you will get the 90 days LMS course access. In this LMS course access only, you have the all 30 days recording session. You can watch anytime. So and then you will get the assignment and task, and then you will get the weekly live sessions for your doubt clearing, and then you will get the resume building ideas, mock test, internship certificates, and then participation certificates after end of the 21 master class, and also 1-month internship also. So and then these all things will get from discounted fee of just 999. So our regular fee is 399. So this so if by using this registration link, you can avail the 1-month internship program. So this offer will close at 22 March. So this is limited time period of offer. So if you want means you will get. So let's move to the coding part. So let's try to write the code for Moray machine. So this is my sequence. I have to detect from my input sequence. So for that I'm just write the module here. module name is a sequence detected of 1011, and then this is my module syntax. So my inputs are, this state changing, and then this all condition based on clock only. So I just write my clock. My input signals are clock, reset, and then in. So these all things, these all inputs, these are signals have only 1 bit input. So the size of the signal is only 1 bit. So these are my inputs. So and then I then another input, like I'm going to write the single code for finding the overlapping output and also finding the non-overlapping output. For that I'm going to use some one additional signal, like overlapping or non-overlapping. No means non-overlapping. So if it is high means, so now this particular signal overlapping or non-overlapping, this particular signal is refers to if it is high means, like if it is 1 means it will do overlapping. If it is low means non-overlapping. So this particular signal is high means it will do overlapping, and then if it is 0 means it will do non-overlapping. So my output is D out. So D out means in the transcript, in the display statements, I will get this output. If it is 1 means I will get my sequence. I got my sequence. So this is my input and output. So for the state, so you can see here I have the. So firstly I'm this example for this is a diagram for state transition. So here you can see here S0, S1, S2, S3, S4. So there are 5 state here. So I want to declare in the 5 state in my code means we have to use for parameter to declare the state. So parameter S0, this is my first state. So if you declaring some parameter means you have to assign some value for that. So that I'm just assigning 0 here for the S0 state. So this is my second. So I just copy this. So I have to register up to 5 state. So this is my first state, second state, and then third state, and then fourth state, and then fifth state. So totally I have 5 states, like S1, S0, S1, S2, S3, S4. So like this only. So I have 5 state, like S0, S1, S2, S3, S4. So I have 5 states. So I just want to assign values. It is a compulsory thing in parameter. So I just assigned value for that parameters states. So and then for the state rank, these things is for registration of. So registration of states. So and then for state changing I just need additional variables like next state and current state. So So I just write create one variable like a current state and next state. So I have to change from this state to this state, S0 state to S1 state. So for that we need two variables to refer the states. So what is current state, what is next state? For that I'm using, and I just written two variables for the state transition. So and then so I just move to my always block. So firstly I will write my reset condition always at. So I'm going to write the logic. It is triggered from passage of clock, or negatives of reset. If any happens, means if the clock is occurred in passage, it will trigger, and then it will execute the always block. So and then if in the reset condition I'm just assigning in the reset condition, my state will be stay in the initial state like a S0 state. So my current state will stay in the S0 state. So S0 state means is nothing but initial state. Else if it is not in reset condition, means it will do the state changing like a current state to initial state. So current state will be the next state if it is not in reset condition. So this is my reset condition. If it is in the reset condition, it will do it will stay in the S0 state. If it is not in reset condition, it can change state. So just like this logic, so I'm just assigning my current state equal to next state. It means I'm just changing the state. I'm assigning the current state is my next state based on our conditions. So we have to write the condition for that. So just use always. So what is meaning of the passage and linkage? So in the first class or second class I said like a clock. So each and the clock pulse having the passage and linkage. So if you listen my previous class, you can easily understand. So you see, it is nothing but if the clock changing 0 to 1, this is a passage. So if a clock is changing 1 to 0, it is linkage. So I just show here. Yeah, you can see this is a passage. Like it is the clock changing from 0 to 1. This is a passage. And then if it is changed here, like this arrow symbol, it will, if this arrow symbol here means, if you have here means this is a negative, this is passage, this is a negative edge. So in the positive edge of the clock, it will change, like it will change 0 to 1. So we can say that it is a positive edge. It is a positive edge triggering. So this is a passage. Negative means it will change the particular clock change 1 to 0. So we can say this is a negative of clock. So and then yesterday told you. So we can detect any sequence by using the Mealy and Mealy, and not only finding the sequence for the FSM is not only finding the sequence. So sequence of 10 only. We can write any logic here. Like if you want to do any projects, you have to use for FSM only. So how means I will tell you upcoming session how to use FSM for other projects, like if you do any simple project like a UR project or any project or simple things, by using FSM only we can write. uh, Without FSM we can write the logic, but if you declare state, if you declare if you divide your project one by one, we can easily assign, we can easily solve one by one step. So we can write the code for our project very easily. So if here my step, I'm just defining states based on that. So if you are having some projects, you are having some logics, so you have to do for divide your budget. So by using step by step process, you have to register for this state, like a base, like this state only you have to register for your particular action or particular condition. So you will move to one by one. So FSM using all the project, so I will tell you upcoming sessions. So by the theory part you can't understand, so it is very hard to explain how it is work means. By using the code it will easily understand. Always at start, if it is any, if it from my signals, if anything is triggered means it will execute this always block. So I'm gonna use here state, sorry, case block, case based on my current input. Based on current state. So if my in the current state is S0, I'm assigning next state. So next state, so I'm checking my D input. If my D input, if my input is 0 means it will stay in the same state. If my input is 1 means it will move to the next state. Same logic here. If my input, so this is my ternary operator. If my D input is here if you write D in means it will check high only. If it is high means it will choose here. So if it is 1 means it will move to an S1 state. So I will move to my S1 state. Here if it is having 0 means it will move to S0 state. So basically if you write only signal name, it means it will check by one high only, or else if you want to check the 0 means you have to write like this logic. So like a 1 bit binary 0. If you write this means if this condition is true means it will choose this. If it is false means it will choose this, like if else condition. So just write here, if D in is high means it will choose this, or else it will move to the, or else it will choose this as output. So same thing for my other remaining states. So I'm just changing. So you can see here in this, from this S1 state, this is for S2 state, this is for S3 state, this is for S4 state. So I'm just assigning the condition where you want to move. Based on if my S1 state, for S1 state I'm going to write, if my input is 1 means it will stay in the same state. You can see here, if my input is 1 it will stay in the same state for S1 state. So if my input is 1, it means it will stay in the same state, S1 state. If it is 0 means it will move to the next state. So if it is D in is high means it will choose S1, D in is low means it will move to the next state, S2 state. For the S2 state, if it is 0 means it will move to the S0 state. If it is 1 means it will move to the S3 state. So S2 state, if it is 1 means it will move to the next state. My next state is S3. So if it is 0 means it will move to the S0 state. So I just write 0 here. So if it is 0 means it will choose here. If it is true means it will choose this. If it is false means it will choose this. So and then let's check for S3 state. So in the S3 state, if it is high means it will move to S4 state. So if it is S3, if it is D is high means it will move to the S4 state. If it is 0 means it will move to where? If it is 0 means S3 state. If it is input is 0 means it will move to the S2 state. So based on my current input. So here I'm going to write some logic for differentiating the overlapping and non-overlapping. So firstly I'm checking my signal, like this signal. So this particular signal is high or low. If it is high means it will do overlapping. So if you write signal only, it will automatically take high. So here you can see this is 2. It's like here it having 1 means. So here it having 1 like this. So and then it check if it is high means, so we have high, so it will choose here. So if it is high means, if it is this particular signal is high means it will do overlapping. So overlapping is nothing but it will, if it is overlapping is nothing but if it is input is 1 means it will move to the S1 state. If the input is 0 means it will move to the S2 state. So again I am using another bracket to define the D in. So D in check. So if it D in, I am checking D in. If it is 1 means, if it is input is 1 means it will move to the S1 state. So it will move to the S1 state. So if it is 0 means it will move to the S2 state. So I just write S2 here. So if it is high means it will do this. If it is low means it will do non-overlapping. So this is for non-overlapping. This is for overlapping. So non-overlapping. So non-overlapping means if it is 0 means, so if it is 0 means it will directly goes to S0 state. So I just write here S0 state. So this is that. By using one signal we can say that a control signal, if it is 1 means it will do overlapping, if it is 0 means it will do non-overlapping. So and then defaultly I will stay, my next state will be saying my next state is S0 only in the reset state or initial state, and then end case. So this is my always block for the state changing and condition. So and then I have to write output for that. Always any signal is triggered means it will execute this always block. So and then end. So here I'm just writing the another case here based on my current state. So if it's like a S4 state, in the S4 state I am just writing D out. D out is my output signal. I'm just assigning 1 bit to 1. Defaultly it will stay in the, so defaultly my D out will be 0. End case. So this why this block means, so I'm getting output D out in the last state, S4 state. For that only I'm using another always block to see my output. So you can see in the fourth state I'm assigning D out equal to 1. In the fourth state only I'm assigning, I'm not assigning for first state, second state, third state. I'm only assigning in the fourth state. Why? Because of in the fourth state only I'll get my output. So that I'm just assigning in the fourth state. So let's check. Let's check. Let's run and let's check for error. Is there any error means? So just choose my simulator. Is Siemens Costa Sim. Then save and then run it. Here you can see I just remove my non-blocking assignment. So just made mistake here in the output. I'm using the D out in the always block. I just need to write H in the output. So and then here also remove my non-blocking assignment. So undefined variable S0, S0, S1 in the 22 SV22 line. So in the 22th line, like a S0, so it means S0 like same thing again. So I just change my parameter value like a 3-bit binary 00 in the binary form to remove my error. 0 means 0, and then 1 here 3-bit binary 0 1 0 for 3. So here I change 3-bit binary 0 1 1 for representing 3. Here I am changing 3-bit binary 1 0 0 for 4. So I check now here I'm getting correct output or not. someone is said like a twin sync. Yes, is a capital letter. I just made mistake on that here on that place. So I just put capital here so that I'm receiving errors. So I just so I just run again to clarify my. So thank you for your response. Yeah, okay. So now I get 0 error. So just move to right for test bench. So thank you for your answer. So not answer, suggestion. So here just write module test bench and then in module. So I just register my signals like a clock reset and then D in and then that particular control signal. So these are my input signal. My output signal in the right. My output signal is D out. So I just create my clock always at every 5 nanosecond. My clock will be toggling. So this bitwise not, and then I just created my clock and then instantiation. So my module name is st_1011. So and then a1 is my instance name. So I just use this method to connect my signals. So and then in the initial begin. So and here I just clock equals 0. My reset is high at the initial time. So and then my D in is also 0 at the time after. So before that I'm just write my display statement $monitor. So I want to see time. So just time in the form of decimal and then state here, and then I have to state if you want to see. So in my IO signal there is no state, so I want to see my current state. For that you have to use for instance name, instance dot your variable in the module like a current state. So this is my variable name in the like design code. I'm just seeing my what it have in my simulation. So for that in the binary, in the form of binary, for that you have to use this way, or else you can use in the. So just write the current state here. So and then D in, in the form of binary, and then D out in the form of binary. So and then comma for time seeing. So if you want to see my time, just need to write $time to see your simulation time, and then for state for see my current state value. And so we have tried here in the RHS side of the display statement. So instance name dot current state, and then D in and then D out. So this is my display statement. So and then I pass my stimulus here inputs. After 10 nanosecond I just off my reset condition to assigning 0 for reset, and then I just give some delay. After that I just pass my D input binary values like a D in equal to 0. Firstly I give correct sequence, one bit 1. After some delay, I'm giving d in equal to 0. So I just copy this. So this is my sequence. Firstly I give 0 and then 1 and then this is my sequence. So I'm just, and also I give one thing also, reset 0. I want to do like a overlapping or non-overlapping. So just here I just click copy this, sorry. I am assigning for this signal. So here this is my signal, control signal. If it is high means it will do what? It will do overlapping. So if it is high means it will do overlapping. So just give 1 for that high signal, high sign, 1 bit binary 1. So it is high, so it will do overlapping. So I just I just write for sequence for overlapping 1 0 1 1. This is my first sequence, and then here I am going to give 0 1 0 1. So this is my second sequence. So I just give some random inputs like 1 0 1 1 and then 1 here and then 0 here. So and then give 0 here. So this is my random binary inputs for my sequence detection. So I just run this. So it will continuously running. Why? Because of I'm using clock here. I didn't write a $finish to finish my simulation at the 20th nanosecond. After this execution, after the 20 nanosecond, I will finish my simulation. Save and then run. Yeah, you can see here output. So initially it having 0 here, my outputs d in. So this is my inputs like 1 0 1 0 0 1 0. So I just change here like a 10. Yeah, you can see here 1 0. Firstly it having 0. I assigned d in equal 0 in the reset condition. In the you can see reset condition is in the state we have reset is high. After that I just remove the 1 here. I just put 0 for reset. I just off my reset, and the time my d in is equal to 1. So this is my first four inputs, sequence inputs. So and then you can see here I got 1 here. So it will give some part of the output like elsewhere here. You can see here 1 1 0 1 1. So in the next clock cycle I got 1 output here, d out equal to 1, and also you can also here, but here I am seeing some random state. So you can also see here my state will be the 1 0 0 0. So at the fourth state only I'm getting the d out equal to 1. So based on my code logic, if I change to the 0 and then I change in the decimal for the state. So you can see in the fourth state I will get my output 1. Here is some mistake here, so it will stay in this it will stay in this state 1 only. You can see state 1, state 2, state 3, state 4, I get 1. State 1, state 2, state 3, state 4, I get 1 here. So this is a rating of Mealy machine FSM. if you did one rating FSM means you can easily understand. So this is for today. So it is easy only if you try. If you try it your own self means it will easily you can understand. So thank you guys, thank you for listening. So we'll see you tomorrow. So this is a rating of FSM in Verilog. So firstly you have to register for states, and then register for, and you have to create for variables for state transition, and then write logic for the state transition. So what will be your next state? What will be your next state? Based on my ternary operator, or you can also use if else condition to choose your next state. So it is based on your logic. So this is the way of writing FSM code in Verilog. So thank you. We'll see you tomorrow. So thank you, Kanika. Thank you, sir. So thank you. We'll see you tomorrow.